Before we dive into the code, let's have a short conversation about the setup that you chose for the 7702 Safe Smart Account implementation.
The setup here we have now is designed such that users have to sign only once, and that is signing an authorization message, and they don't have to sign the init data again. This provides a better UX to the users, and how it works is that address of the proxy is dependent on the init data. So user signs the authorization to a proxy, and the address of the proxy depends on the init data. So kind of we are killing two birds in one shot. Let's get started.
Yes, this is a repository. I'm going to clone it on my local machine.
The first main and important component is the contracts. Primarily, it has a proxy contract and a proxy factory, which has been customized specifically for EIP-7702. Other components are like a UI and a backend, which is still in development. But right now, we will just focus on the contracts.
So here's the contracts folder in my code editor. And I'm gonna npm install. What is the first step I do with this repository?
After installing the dependencies, you need to set up the environment variables, which contains a private key of the account, which would be converted into a safe smart account, and a private key, which will be used for sponsoring transactions.
Right, so I guess I copy and paste the env.sample, and I call it .env. The relayer private key, which should be an EOA account with some ETH.
Right, it should have some native ETH balance required for paying the gas.
And this is the account private key, which is the private key of the EOA we want to convert to a smart account.
Correct.
Perfect. Let's have a look at the hard hat config, because there's something important.
So this hard hat config readily has configurations available for using Pectra DevNet, and we will use the same, so we need not set up any RPC URLs here because it's already done for you.
So what we did now is we added two private keys to the env file. We will not show the env file now. And what we also did is we used a faucet like this one to mint some Pectra ETH on the DevNet. What are the next steps?
So the first step that we'll do is send a type 4 transaction through a relayer, in which there will be an authorization which will be signed by the EOA account who wants to be converted into a smart account.
So I open source scripts code, and this file has some imports. A setup function, what does it do?
The setup function imports the default addresses to which the contracts are deployed, and this information is required for deriving the address of the proxy to which the account will delegate to.
Right, so this is basically the safe smart contracts that we deploy on every chain to make sure every user gets the same safe address on every chain.
Right. This information is like the address of the singleton, fallback handler address, some modules that you want to be enabled by default. And these are right now deployed on the Pectra DevNet, which we are using for our demo purposes. If they are not deployed, you can just deploy them using the deploy scripts, which are ready for you.
Perfect. But we don't need this now. We only need the main function.
Right. You can see in the main function that we have a bunch of imports. We calculate the proxy address, calculate the setup data, and then the user signs the authorization message, which then gets relayed in one transaction, and then there is one more transaction to set up the storage of the account.
How can we run the script?
The instructions to run the script are available in the README. Just go over to README and you can copy the instructions from there.
Right, so I guess this one?
Yeah.
So I copy and paste this into my terminal and run it.
Yeah.
So as you can see, we ran this command a second time because the first transaction didn't go through. So this is why we see the message proxy already deployed. And the important messages come here. We set the authorization And then we have some storage slots very close to the metal. What do these say?
So these are the storage slots of the EOA account. You can see the storage slot 0, which stores the address of the safe singleton to which the EOA will delegate to through the proxy, which means that the EOA account is now a safe account.
Nice. So this is the most important storage slot. We won't go through the other ones. But what we can do is we can inspect the account at the Pectra Explorer.
Yeah, let's go and see what's there.
So I copy and paste the address of the account into the Pectra DevNet Explorer. And I open the page, and what can I see here?
You can see here that the account is now delegated. If you go into the contract section, you can see the code for the EOA is spitting out some numbers, and it means that the EOA is now converted into smart account.
Amazing. So this address or this bytecode here should be the same address as our proxy. This is correct?
So the first 3 bytes, EF0100, are the EF is a band opcode, and except the first 3 bytes, you can see the address of the proxy.
So this A522 should be the same address we see here, and we see the proxy which is deployed has the same address.
Right.
Nice. So we can also inspect this address, which is the proxy.
Yeah.
With our bytecode.
Yes.
And I guess we can also inspect the singleton address, which would be here.
Right.
This one, CF, and so on.
Yeah.
Let's copy and paste this over with 0x and this address. So this is now the smart contract code that executes when the EOA is called as a smart account.
Yeah.
But it still has a private key, right? So better don't lose your private keys.
Yeah, users can still delegate to other accounts using this private key. So it still needs to be kept securely.
Right. So this was the address, and the EOA can always change the delegation designator.
Correct. Right.
Nice. Let's have some fun. Let's do something that an EOA could never do before.
Yeah. So we have one of the scripts where you could patch multiple transactions into one. For example, you can send ethers to multiple recipients in one single transaction, and also have that transaction being sponsored by some other account.
How can we do this with your POC?
So let's go into the script.
So I go into source scripts batch execute number 3. Again, we have some imports and the setup function for the safe smart contracts, and the main function, which is of interest for us now.
Yeah, so in the function, you can see that we have a meta transaction object, which is an array of transactions which will be executed through a multi-call.
So this is an array of different transactions. We send some balance from the relayer to the EOA because remember, the EOA doesn't have any gas. All of these transactions are sponsored. So then we pack these transactions into this multi-send and send it as a relayer.
You can go into README, copy the instructions from there,
and copy and paste it into my terminal. Let's have a look. So this is now a sponsored batched transaction sent by an EOA. So I copy and paste the transaction hash into the Pectra inspector. Because the contracts are not verified, the logs are not very useful. So we go into the state changes.
We can see a bunch of transfer of ethers that we intended to do in the transaction, and you can just see that there are 2 addresses received 1 ether each.
This is amazing because this has not been possible before EIP-7702. So this is it from our side. We hope you enjoyed this video. You can clone the repo onto your local machine and follow along with the video if you want to test it out yourself and experiment with the 7702 features. We hope that you choose Safe as the smart account because it's better proven, it's very secure, it's very usable, and has this huge ecosystem of modules and 7579 modules. Thank you very much, Akshay, for programming the POC and showcasing it to our viewers here.
Thank you. It was great to show what we have in the house when 7702 gets launched.
Yeah, right. We are looking forward for the future that gets closer to full account abstraction. We wish you a great day. Ciao, and ciao, Akshay.
Ciao.